Lecturer Joe here. Today we're going to take a look at relays. So relays are used throughout electrical engineering, so it's pretty important to understand how they work. And an understanding of relays is also your first step to understanding how to program PLCs. We've got a few relays here. This is a fairly common format of relay. You may have seen that before in a control panel. This is the sort of relay you might have on an electronic board, and this is a very old relay from our railway system here in Northern Ireland, and this is where we're going to start because it's big enough that we can see inside it and take a look at the parts. So opening up this relay, it consists of two parts like all relays. This part here, which is the coil, and over on the right hand side we have the contacts, and those are really the only two parts there are inside a relay: coil, contacts. So the coil is, as the name suggests, just a coil of wire. We'll come back to what that's used for in a moment. And the contacts here are a series of, if you like, switches. Now we usually don't refer to them as switches, we refer to them as contacts. Similarly, when you're programming a PLC, you'll come across that as well, coil and contacts. So some things worth noting here: there's only one coil. So every relay just has a single coil. However, there can be many contacts. And some of these contacts, when the relay operates, they will close to turn something on, and other contacts will open to turn something off. And if I force the relay by hand here, you can see that some of those contacts open and others close. And this means that on a single relay we can be turning on several different devices and simultaneously turning off several different devices. And that's one of the main purposes of a relay. It enables one signal to turn on several devices or turn off several devices, or a combination of both. Now you saw me operating these contacts by hand just by squeezing down this lever, but of course that's not how we want the relay to actually operate. So this coil, you might remember back in your high school physics class that if you take a coil of wire and pass an electrical current through it, it becomes a magnet. So if we pass a current through this coil, it'll become a magnet and it will suck down this lever and thereby operate these contacts. Now in this particular relay, the coil requires 24 volts in order to energize it, turn it into an electromagnet and operate the relay, become a magnet and suck down this lever. So I've got a 24 volt supply here, and if I put it onto the ends of the coil, you'll see that the contacts move over. 24 on, 24 off. So by switching on a single 24 volt supply, we energize this coil, we move these contacts, and we can turn on and off a whole bunch of other electrical equipment. And an important thing to note is that although we put 24 volts on to energize the coil, these circuits can be any voltage. So these are just like switch contacts. So these can be turning on any other electrical circuit at any voltage. And that's another key point about a relay. Not only can you turn on and off several different things from one electrical supply, one signal, but these things can all be on different circuits at different voltages. So in this relay, the coil here is 24 volts. We've got to apply a 24 volt supply to the ends of the coil, the two contacts here, energizes the coil, pulls in the lever, moves the contacts. Some of the contacts are normally open contacts, meaning when there's no supply on the relay, they're open or off. Other contacts, like this one here, are normally closed, meaning when the relay's off, they're in a closed position. And those contacts are mechanically linked such that when one moves, the other moves. So these are normally open, and that's often abbreviated to N.O. These are normally closed, N.C. And when the relay is energized, they all move at once. The normally open contacts close and the normally closed contacts open. So let's get rid of our antique relay and look at one that is much more modern. So this is the sort of relay you're likely to come across within electrical engineering inside a control panel. And if we zoom in on it, you see it's the same deal. Here we've got a coil, and again it's 24 volts. And here above it we have the contacts. And you can see here that the top contact is closed, the bottom contact is open. This is actually a changeover contact. So when the relay energizes, this lever pulls down towards the coil, and the middle strip of the contact here moves from the top to the bottom. So this is what we have on this little PLC. We've got a single coil. There's always only one coil. Sorry, this little relay. There's only ever one coil inside a relay. But here we have two sets of contacts. Each contact set 1, set 2, is a changeover contact. So we have a middle connection here, which is sometimes called the common. And then we have a normally closed and a normally open. And the same thing here. And these both move at the same time, so that when 24 volts is applied to the coil, the contacts move over to this position. When the 24 volts is taken from the coil, then they move back, as you can see here. So one coil, two sets of changeover contacts. That means that our relay must have 1, 2, 3, 4, 5, 6, 7, 8 connection points. And sure enough, you can see those 8 screw connection points here. We've got 4 along the top, 4 along the bottom. And this black base is really just, well, exactly that, a base. It's just a way of making a connection. The relay itself has these pins on it. It's a little bit hard to wire to, so you always got to use a relay like this with a plug-in base. Sometimes called an octal base, octal for 8 because it's an 8-pin relay. So let's recap then. A relay is basically an electrically operated switch, by which I mean a regular light switch in your living room, you got to poke your finger on it to switch it on, whereas a relay, you apply a voltage to the coil of the relay in order to switch it on. And we talk about energizing it rather than switching it on, because obviously the contacts, as we mentioned, could be turning something on or they could be turning something off. So we energize the relay by applying a voltage to the coil. And the relay has one coil, but it has one or more contacts. So you remember the large old relay we looked at the start there had multiple contacts on it. And lastly, the coil is usually a low voltage, e.g. 24 volts, like the relays we took a look at there. However, the contacts, they can be switching higher voltages. For instance, mains 230 volt AC.